We all want smarter AI, right? But what if the smartest thing an AI could do is be smarter about how it uses its own power? That's what we're digging into today, this idea of resource-aware optimization. I love this question because it just gets right to the point. Think about it. Would you really grab a massive sledgehammer just to tap in a tiny nail for a picture frame? Of course not. It's total overkill, right? Well, believe it or not, that's pretty much what's happening all the time in the world of AI. So, here's what we're going to cover. First, we'll talk about this one-size-fits-all problem. Then, we'll get into the solution, which is something called smart routing. We'll peek under the hood to see how it works, and then we'll get real about the biggest upside, cost, and the biggest downside, which is complexity. All right, let's dive into the core problem here. When we think about AI, we usually picture these gigantic, all-powerful brainiac models. And hey, they're incredible, no doubt about it. But using that same powerhouse model for every single question, no matter how simple, is just, well, it's not very smart, is it? And here's the kicker. It really matters because these top-of-the-line models are insanely expensive to run. We're talking big bucks, tons of computing power, and a whole lot of energy. Seriously. Asking a genius-level AI, hey, what's the capital of France? That's like hiring a world-renowned physicist to help you with third-grade math homework. It's just a crazy waste of resources. So, if that's the problem, what's the fix? Well, that's where something called smart routing comes in. The whole idea is beautifully simple, really. Stop treating every task the same. Instead, you build a system that's smart enough to manage the workload. And this leads us to the big idea for today. Resource-aware optimization. It's one of those terms that, thankfully, means exactly what it says. The system gets aware of its resources. It looks at a new task and asks, okay, how hard is this, really? And then it looks at its toolkit of AI models and thinks, which one of you is the best and cheapest fit for this job? It's basically a matchmaker for AI tasks. And look, this isn't just some abstract academic idea. It's super practical. You can see right here where it shines. For any company that's dealing with a flood of requests and has to watch its budget, which, let's be honest, is pretty much everyone from a big enterprise to a growing startup, this kind of optimization isn't just a nice to have, it's an absolute game changer. Okay, so we get the what and the why, but how does it actually work? What are the smarts that make this routing happen? Let's pop the hood and take a look. The absolute core of this whole thing is what's called a router agent. And honestly, the best way to picture it is as a super smart dispatcher, like an air traffic controller, but for AI requests. Its entire purpose in life is to look at every single request that comes in and figure out exactly where to send it. And the process itself is actually pretty straightforward. It boils down to these 3 steps. 1, a new request lands on its desk. 2, the router agent immediately sizes it up and sorts it into a category. Is this an easy one, a medium one, or a really tough one? And then step 3, it sends that request to the perfect model for that specific job. The cheap, zippy model gets the easy stuff, and the heavy-duty, expensive model is saved for when you really, really need it. But wait, it gets even cooler. This isn't something you just set up once and walk away from. Oh no, the router agent is a busy little bee, constantly keeping an eye on everything in real time. It's watching API costs tick up, it's counting tokens, it's checking the system's workload, and if it notices things are getting a little too pricey or a bit sluggish, it can actually adjust on the fly and maybe reroute to an even more efficient model. It's pretty amazing. So you might be thinking, okay, that sounds like a lot of work to set up. And you'd be right. So why would anyone bother? Well, it all comes down to one absolutely huge, undeniable benefit. And there it is, money. We're talking about a significant cost reduction. By putting that expensive sledgehammer away and using the right tool for the job, companies can slash their AI operational costs. And I'm not talking about finding a few cents in the sofa cushions here. For any company processing thousands or millions of requests, this can mean saving a fortune. Literally. But you know what they say, there's no such thing as a free lunch. And to be totally fair, we have to look at the other side of the coin. All that efficiency, all that cost savings, it doesn't come for free. And here are the hurdles. First off, just building this thing is way more complex. It's not a plug-and-play solution. It needs constant tweaking and calibration to work just right. And maybe the trickiest part of all, trying to teach a machine how to reliably tell the difference between a simple task and a complex one. That sounds easy, but in practice, it's a really, really tough nut to crack. So this really boils it all down, doesn't it? It's a classic trade-off. On one side, you have this huge, glittering prize, massive cost savings. But on the other side, you've got the reality of more complexity, more tuning, and more headaches to get it right. It's the ultimate engineering question. Are you willing to put in the hard work up front to reap the rewards down the road? And that kind of leaves us with this big final question to chew on. We're always so focused on making AI more and more powerful, more and more capable. But what if the real challenge, the thing that will define the next chapter of AI, isn't about raw power at all? What if it's about efficiency, about being resourceful? Maybe the goal isn't just to build the smartest AI, but to build the one that's smartest about how it works. Something to think about. Thanks so much for tuning in.